In this video, I'm going to be going over the basics of the Lua programming language and how you'd get started uh, learning to program using Lua. Now, I'm not going to start at the real basic level. I'm going to assume you have some sort of basic knowledge of things like variables, functions, types, and controls, for example. And really, if you don't even have that knowledge, I don't think you really need that to start with. These are things you can pick up along the way, as long as you're prepared to do a little bit of research and a little bit of study. So don't worry too much if you haven't got that sort of knowledge. But I'm assuming I won't be describing those sort of things in detail. The other thing is the Lua interpreter is found here. So that's the home page for the Lua interpreter. In this particular case, I'm using the Zeus IDE, which comes with its own version of Lua, so I don't need to install anything. But if you're using another editor, you'll have to download and install the Lua interpreter to work through these examples. So that's just an overview of what's coming. So let's get started with a very simple Lua script. We'll start with a print function and a string. So right there, I'm calling the print function, passing it a string, hello world. Currently this file is unsaved, so first thing I have to do is save it. So I save it to disk, and I'm going to call it example1. Example. Now, to run it, I need to use the Lua interpreter. So to do that, I need a command prompt. So in Zeus, I can do that through this .shell command. And that's just a terminal prompt, a command prompt. Again, I'm not going to go into the details as to how to use this. I'm assuming you know your way around the terminal. One thing I can say, if you need some information on how to learn how to use this command prompt, a good start is just use the help command, and it'll give you a whole bunch of different options on what you can do in the command prompt, and then you can get further information on something. So if I go help CLS, if I look at that CLS command, well, let's start with sort. Probably can guess what sort does, but you can drill down into sort and it gives you further information about that. As I said, I'm not going to go into those details, but to run the Lua interpreter, you need a command prompt. And what you would be doing is going lua.exe and then passing in the example file. Now before I do it, I'll use one of these command prompt commands. I'll use the type command, which actually display the contents of the file. As you can see, that's our script. That's the contents of that file. And if I now run this, I get this message. Now this would indicate that you haven't actually installed Lua, or you haven't configured it properly. And again, I'm not going to go into that detail because I'll leave a link in the video on how you can set that up. But basically that means you need to go to the Lua page, download the Lua and install it. But in this particular case, because I'm running Zeus, it actually comes with a version of Lua pre-installed. So once you've done the installation, it's already configured. And it just so happens, because it doesn't want to run into the official version, it calls the executable by default, matching the version number. So it's running version 5.4 of Lua. So now when we run, what we've just done there is we've run the Lua interpreter, and I can display that by saying version. If I type in the right command, I still haven't got it right. -v, as per the hint. there you go. It's running the Lua 5.4 interpreter. And that's because this is the one that comes with Zeus. If you actually went to the lua.org page, you could download and install it, and it would just be called lua.exe. Now this thing actually also comes in a REPL version. You can actually do without anything. It actually opens up like a REPL, and you can do things in here like A equals 1, B equals 2, and then you can print A times B. So it's like an interactive environment. So that's a quick, brief overview of that Lua interpreter. But let's ignore this for now, because, well, let's remember one thing, that when I run the script through the interpreter, I get a result. Okay, so that's one thing to remember. So right here back in Zeus, I've got the same script. I can actually run that same script using this Lua script, and it's actually going to run that script through the interpreter. So let's do that. And lo and behold, we get the same result. Naturally, if I start changing it here, I can make some changes here. And I can run that script again. I don't even have to save it. The script will save it. I get my changes. So that's why I don't really want to get involved in that DOS shell, because you can do it all from inside the Zeus IDE. And in fact, you can even use the REPL inside here if you like, because I can go over here and I can go to my language shells and I can run this REPL. And again, I can do the same thing. So you can do, because Zeus is scriptable in Lua, it comes with a Lua environment. And what do I mean by scriptable? Well, let's close this thing first. Here I am in a text file. I can actually go to the macros menu and record a keyboard macro. So I can go So I type something in, and it's in record mode. You can see the record mode in the status bar. It's got the rec there showing, and I can stop recording. It tells me it's stopped recording. I can view the source code. It's actually created a Lua script, but it's a Zeus Lua script. And so now if I play that macro back, it just plays back what I typed in. And naturally, if I go in here and I change this, and I use my playback this time, it plays back. And you can use the accelerator key, so you can. So basically, that's because it's scriptable. It has a scripting engine to let you script the editor. As part of that, you get a Lua environment for free. Hence the reason I can run this through that menu. Now, not only that, it's got this syntax checking ability. Lua has a way to parse, so you can parse for errors. So if I actually deliberately put in a syntax error, and I use the compiler menu, it'll tell me there's a compiler. It's running a syntax check on it. It's using the Lua interpreter to parse the text. But enough of that. Let's get on to something more meaty. This is now, so that now we've described the environment, and you can do, all of this is neither here nor there. Just to do any programming, all you need to do is make sure you have the Lua interpreter installed. And you can use any scripting engine to run it. And all you have to remember is to run something, you take the lua.exe. If you were using something other than Zeus and you're doing it manually, you take a lua.exe and the name of the file. Okay, so that's the magic source. It just so happens you're getting this built in because it's doing it for you. But that's really as simple as it is. That's all you need. But now let's get onto the task of actually learning the language. as I said, the first thing you'd do is download the interpreter. You'd go to the home site, the web page. Here is another macro which takes you to the sorry, that's not the right one. It should be actually, it's there, Lua reference manual. It'll actually bring up the language reference manual for the thing. Definitely worth a read. It's actually just linked off the Lua homepage in the documentation. So that would be the next step, learning and that would then teach you about these things like variables, functions, types, and controls. But another way to go is to actually just start with some of the examples. And here we've got some of the examples copied from the Lua web page. So here's our hello world. And as you can see, they've come up with a different version of hello world where they're actually displaying the version number of Lua. So let me run that. And sure enough, it's showing Lua 5.4. Now, this is what I would recommend for learning any particular language. What you have to teach yourself is how to read code. I think a lot of programmers get stuck because they think they have to memorize things. They spend an eternity trying to figure out, how do I remember all this stuff? You really don't need to try and remember that stuff. What you need to teach yourself is how to read code. And the way I recommend learning that is taking a bit of code and then writing what you think it does. So in this particular case, you can see that this is doing something with this IO, and it's looks like a write function because we know that this little bracket here is a write, and we know that they're strings, and we know, I don't know what this is. This is some underscore version. I have to remember what I have to. So all you do is you make little notes of things. Oh, this is this IO. I'm not sure what that is, but I better look that up. Oh, I know this write. That looks like a function. So I think that's a function. Write function. So I'm calling the write function. With hello world string. So you add a little comment, trying to describe what you think it's doing. And just remember, these are all comments. So they will, over time, you'll go back and you'll read that comment. You'll say, oh my God, I got it so wrong. It's nothing like that at all. But the actual task of writing the comment will help you remember, will help you, teach you how to read the code. And you don't have to worry about getting it 100% right. You just need to start doing it. So you type in the code and then you write in a comment to describe what you think it's doing. So in this case, we're calling this, I don't know what this IO thing is. We'll find out. Bits you don't know doesn't really matter. It just means that that's something you need to look up. You need to do some more research into what this IO thing is. And then you'll find out it's just a module. It's the IO module. But let's take another example. So these are all from this the demo page on the Lua homepage. Here's a bisect one. So again, you would actually go through and if I run this bit of code, I can run this and I can check the output. Oh, so I've got some output. So you go through and you now try and describe what the code is doing and so on and so forth. And I'll give you an example. For the next one, I'll go through what I would do. So here's our globals function. And I won't show that. So this is, again, coming straight off the demo page. If I execute this, it produces a whole list of output like this. And you think, oh my God, what's this all about? But now you go through and you actually can start putting in some comments. So this is the sort of thing I would do. So this is a global table variable called scene. And it's used to remember whether the table has been seen, hence the name. Here we have another local table variable called s, We have an integer variable called n. We loop through. So this is an example of all the different types of comments you would put into your code. So it describes what the code is doing. And a good example, and you can play around with it. This is where you learn. You learn. So for example, if I run this code, back to my menu, run this code, you can see that all these values are nicely sorted. If I go back to this thing, and if I just actually close all but that one, don't worry about that. So we're back to this guy, this global one. If you remember, these were all sorted. So chances are, I've actually closed the wrong one. This is the one I wanted. Here's the line that we think is doing the sorting. So if I comment that out and run the code again, lo and behold, all the data is no longer sorted. Look, it's just coming up in random order. So right there, I know, yes, that's exactly what that bit of code is doing. By putting in that line of code, I'm getting a sorted output. It's just sorting the contents of the table. So it's taking that value there, this table, well, it's actually using the table namespace and sorting the table called S. So S is the table. And you can see S was this local table that we defined up here. So suddenly you're getting an insight into the code. Another nice thing, I noticed that when I looked at this is this G variable. This is a, so what that is, this is a, if you do an internet search for this, this is this G is a global variable that holds all the Lua environment details. And if you actually look at the output, when we run this, you can see one of these global variables in this G is this version. Well, we know what that was. That was in the hello world. We used it over here. So suddenly another piece of the puzzle is falling into place. Oh, this is just a global variable. Ah, right. When I ran this one, and I ran that thing, I got this value here, because I can change this code right here to just do this. Right here, I can just change that to do this. Comment that line of code out again and run this again. Ah, see, so that's what that is. Now I've filled in another little piece of the puzzle. I can actually add a comment here to say this global variable holds the version number. Okay, I filled in a little piece of the puzzle. That little gem will stick with me a little easier because now I understand it. I haven't memorized anything. I've learnt about it. And as you learn more and more of this information will stick. Now what's interesting is if we run this thing over here, and this is why I've got this value, this document over here. If we run this macro here, we've got our little global variable right up the top here, but it doesn't show any value. What's going on there? Okay, well, let's see. Well, what we can do is we can just change this line of code right here. I'll put the code in first. As you can see, I was playing around with it because I was learning a little myself. So now if I run this little bit of code, lo and behold, I've now got all the values. So these are the values, and there you go. There's our version number. That's that same version number right there. So the code change I made, which if I compare it to the original one, I'll put the two next to each other. This one didn't, I've added this extra little bit of equals. I've added that little bit of code. And so what I've actually done is if I comment back this thing, put this one back, let's keep that as the current one. We don't want to, and if I run this again, you can see what these things are. This is like the key value. These strings are the keys. They represent the keys into the global value, which is why if you use that underscore version as a key, it returns a string value, which is the actual value. So right there, all I did was, okay, well, I know what we're doing here is we're printing out all the keys. Well, let's use the key to actually access. So here's the key, and the value of that key is actually equal to that. So we're indexing it. We're using the key to actually index the value. So if I actually now run that, it's actually saying this key in the global variable is equal to that value. So if I run that again, lo and behold, we now have this key is equal to this value. And you can see all the other values have got other things stored in them. Some of them are nil, meaning they're undefined. Some of them are defined. These are all, and they show this is a function type. So a lot of these I pairs they've actually got, so it looks like in the global variable space, you can actually put in your own functions. And some of them are defined, some of them are not. But right there, you've now onto another part. There's more to learn. There's always something new to learn, but you found one little piece of the puzzle. And I'll just, as an example, I'll show you another. This is the way you iterate through a bit of code, getting some understanding of it. And you can, the beauty of this sort of stuff is you can just change it, and you can make more versions of the original, and you learn more and more as you go along. And at each step, you just put in a little, you put in a little comment to describe what you think's going on, and slowly but surely you get a little bit of understanding of how the code works. So as another example, we've got this comment here. This function calls recursively, so it calls itself. As you can see here, it's calling dump. Well, here it starts by calling dump, which is defined here, and then this thing here calls itself. So it's calling recursively. It's calling. A lot of people have trouble understanding recursion. Well, this is an example of recursion. It's the function's calling itself, and it only calls itself if it's a table. So basically, it's dumping the contents of all the tables. So we could add a little comment here to say this dump function dumps a table. That's what it's designed to do, and it recursively calls itself. But if you look at this I value, you think, oh, it's an indent value, I think. How does it work? Well, if you look down here, it starts off as a string there. So the indent value starts off as a string, and here it's actually added a tab to the string. So every time it gets called nested, it adds another tab to it. And we can check that theory by just making a change to the code. And rather than putting in tabs, let's put in dots. Let's have 4 dots. So let's see what happens now. So right here we're testing. We're testing our theory. This is what we think it's doing. Let's see if that is the case. Is this I value the indent value? If I run it again, lo and behold, we've got these dots. Now again, this is a bit confusing, isn't it? Because where's this space come from? What's going on there? And you then look, this is the only place it prints, right? Right here is its printing, and here is the indent value that it gets printed. So what happens if I just do this? Again, this is the sort of investigation you would do as you're trying to learn, trying to understand what's going on. If I run that, lo and behold, yeah, looks like that's the right line. That's no indent now at all. So why are we getting a space? Well, this is where it gets a little bit tricky, and some of these little things can be quite difficult to track down because we're passing in with a comma. By default, the print function will put in some space between the two variables, and it uses spaces. So if we just did this, which is the concatenate command in Lua, now it's going to concatenate the two of the variables together, not put the space between them. Now let's see what happens. And lo and behold, we've lost that space problem. You can see there's now no spaces. We've just got pure indent of of the and again you can compare the two. In fact, let's run them like that. Now we'll have duplicate lines. And you can see here's the one without the indent, here's the one with the comma. So it adds a space between the two variables. And so slowly but surely you can get an understanding of how the code, this is exactly how you learn to program. You don't try and remember all of this stuff, you just try and play with the code and then try and figure out how the code is working. It's a big puzzle. And generally what happens is the process you use is you make lots of these little notes. So you're trying to get to the stage where you can read the code. And then when you have a problem, you go and do a Google search. Now, for example, to try and solve this problem, what you would end up doing is going to the Lua documentation and reading up on the print function. And somewhere in there it would tell you that that's what's happening. The fact that the comma always puts in a space. But there you go. That's the sort of process you would go through to teach yourself how to program. Now, it all might sound very daunting to start with, but it's really the good thing is you can't do any harm. You can just go in here and you start playing with code. So you find someone else's code, and then you try and understand how it all works. Now, sometimes you can find that it's quite difficult to understand, but that's why coding isn't easy. But the more you try, the easier it gets.